Number 1, in the given equation, b and m are constants where m is greater than 4b. We have a quadratic down below, and they tell us the sum of solutions is 3m plus 27, which means they want us to calculate the sum of solutions. So you could distribute everything, combine like terms, and do negative b over a. But since both terms have x minus m, if I just get this to the left side, I can factor it out, and then we can get our solutions that way. So kind of rewriting this, x minus m squared minus m minus 4b times x minus m. I can see both terms have x minus m, so I'm going to factor this out. And what's left is x minus m minus m minus 4b. If I would redistribute, I would just get back to where I left off. So again, this is already technically one factor. So if I just combine like terms in here, we would get x minus m plus 4b. So finally, my final factored form is going to be x minus m times x minus 2m plus 4b. And then each of these should be equal to 0, right? So to kind of write that out, x minus m is equal to 0. So x is equal to m. That's one solution. My second solution, x minus 2m plus 4b is equal to 0. So at the very bottom here, we have x is equal to 2m minus 4b. That's it. Those are my two solutions. They wanted us to, have the sum of them. So I could say m plus 2m minus 4b is equal to 3m minus 4b. And this is equal to this. So I could just subtract 3m from both sides. And I get negative 4b is equal to 27. Divide that by negative 4. And we have solved 4b. Number 2. Two streamers, Nova and Pixel, are saving up for a custom gaming PC. Nova saves 3/8 of her monthly income, and Pixel saves 2/5 of his monthly income. Together, they save $4,200 each month. I want to dive into an equation, right? Below, we got 3/8 of Nova's monthly income plus 2/5 of Pixel's monthly income, and that should get us $4,200. And then in the last segment here, they say if N and P represent their monthly incomes, which equation shows the relationship between the two, right? So all they've done is they've taken our equation and they've manipulated it in some way. So the number one thing I want to notice here is there's no fractions. So if there's a way I could get rid of both of my fractions, it's going to look much more similar to one of my answer choices, right? And it's going to be easy. All I have to do is multiply everything by my least common denominator. To get that, I just multiply these two. 8 times 5 gets me 40. And you're going to kind of see how that results. So if I multiply this by 40, 40 over 8 gets me 5. So 5 times 3 gets me 15n. Multiply this by 40. 40 over 5 gets me 8. 8 times 2 gets me 16p. And then finally, you probably guessed this is where the big number comes from. If I multiply 40 by 4,200, I get 168,000. And that's it. I get answer choice B here. Number 3. A server admin initially records 8,000 players online in a new Battlefield 6 mode. 4 hours later, the player count reaches 32,000. Assuming exponential growth, we have our formula here. And they say, given that the number of players n is after t hours, k and p are constants, what's p? So we want to be really comfortable with our exponential functions. Remember that k is our initial, so that's just going to be our 8,000 start. N is your result. That's going to be turning into 32,000. And then they also gave us t as 4. So I'll kind of get rid of this, and we'll say it's being raised to the 4p. So we have a function, we have one variable, it should be pretty easy to solve for, and of course, I'm not going to do any algebra by hand, I'm just going to open up Desmos. So I already have the function typed in here. Notice how I have everything typed except I changed p to x, because what that does is it has Desmos automatically solve for it. So when you get these lines that don't have a dot, I mean, of course, if you want, you can like zoom in to see what it is, but there's another trick. The reason why it gives us these vertical lines and not like a function is because of our equal sign. all you have to do is subtract one of them to the other side. So say I wanted to make this subtract 32,000 from both sides, so minus 32,000. I get rid of this because I subtracted it from the other side. And now I get my function again, but now I get a dot. So I can clearly see my p-value is going to be 0.5. And just to double check on my paper, it's going to be A. Number 4, we have a circle, and it has its center at 5, -2. So some circle practice. We're going to ignore answers because we want to prepare for, any type of answer choices. Remember that it's going to be x and the opposite of what your center is, squared. So because it's +5, you make it -5. And then it's plus your y, same thing. It's going to be the opposite. So it's +2 because it's -2 up above. And then finally, it's equal to your radius squared. So you should notice squared, squared, squared. And then finally, they give us a point. Remember, a point is an x and a y. So all I would do is I would plug in 1 for my x. I would plug in 7 for my y. And I can solve for r. But I'm not doing any algebra by hand. I'm just going to plug this in Desmos. So I already have our function here. I have the 1 in for x, the 7 in for y. And then again, when you want Desmos to do your algebra for the letter you're solving for, you make it x. And it gives me this weird value. But remember, I don't want radius. I want radius squared. So instead of typing that, I'm going to go ahead and export it. I'm going to get rid of my, coordinate notation. And I'm going to square it because they want radius squared on the right side of my equation. And anytime you see a value like this, what it means is there was like a repeating decimal, but 97 is actually my value. So I go back to my paper here, and I say that my r squared is actually going to be 97. So looking through my answers, I get rid of D because it's a 25. And then I want to look for -5 and +2, and it looks like it's going to be C here. Number 5, I see a linear equation, m is a constant, and the equation has infinitely many solutions. Anytime I see infinitely many solutions, linear, I go ahead and I break this into 2 equations. And that is because if I would graph both of these, I add a slider for m, and I just make it so they line up with each other because they're the same line. So I open up my Desmos here. I got both my equations typed in. I add my slider for m, and it looks like positive takes us further away, so we want to go negative here. I make it something maybe like -30. It's close. I zoom in a little bit here, and I just have to get them to line up. Super easy on Desmos. We see that m is -28, so I'll go ahead and I'll write that down here. But we do always want to be prepared for when Desmos doesn't work here. I would say it's like 20% of the time it's not going to line up super well. And that's when your answers are like fractions, right? Like if my m was -5/9 here, I'm not going to get that to line up on Desmos because it's a repeating decimal. So if that's the case, all you have to do is get them both in slope-intercept form. So I distribute this, and I would get 12x minus 84. And that's supposed to be the same as 3x plus 3m plus 9x. So combine like terms. This turns into 12x plus 3m. So my 12x is already equal to 12x. Therefore, -84 should be equal to 3m. And if I divide by 3, I also get -28 is equal to m. Not bad. Number 6. The first thing I want to do when I see a graph like this is identify my solutions, my x-intercepts. Looks like it's going to be -4, +2, and +5. Down below, they call this h of x, and I see a horizontal translation. And I also don't see a mention of solutions, but I do see factored form, specifically 3 factors. So we just want to turn our solutions into factors. You just throw them in parentheses with the opposite sign. So this one's going to be x plus 4. This one's going to be x minus 2. And then this one's going to be x minus 5. I also noticed that like 2 of them are squared and 1 of them doesn't have a square. And that's because of how it hits the x-axis. This one that just goes straight through, that's going to be our normal, just raised to the power of 1. The ones that kind of bounce off are always going to have a power of 2 or more, 2, 4, 6, etc. So we know that P and Q are going to be these, and I know that R is going to be this one. So I want to throw this in Desmos, which I have right here. And again, I just have exactly what's typed here. You can see our graph. It looks really similar to what was on the problem. All I have to do now is throw our translation. So our translation was at h of x minus 12. You can see our second graph over to the right here. And since this one is already helping us define it, but we don't actually need to see these values, I just hide that. Scroll over here, and we have our R value and our P or our Q value. We don't know which one is which. Finally, they ask which one could be the value of Q. All they're specifying is we want one of the ones that's squared. So we want one of these two to the right. And finally, it looks like our answer is going to be 14 or 17, and that's going to be answer B. Doing it by hand, again, our f of x is already defined. So when I see f of a, I can just plug that a in for x. So f of a should also be equal to 4a minus 9, and then I just added the rest of my equation, plus 5 is equal to 3a, or 4a minus 4 is equal to 3a. I can subtract 3a from both sides, and I can also add 4 to both sides. That cancels out, and you actually should just get a is equal to 4. Not bad at all. Number 7, using regression on Desmos. So when I see this f of x function, I want to plug that into Desmos, so f of x is defined. Then in my next line, I'm going to set this equal to this, but using a tilde instead of an equal sign. So we'll pull up Desmos, and you can see I have my f of x function up here. I have the left equation, and then instead of an equal sign, a tilde, and then equals to this equation, and it tells me immediately what a is. A is going to equal 4 here. Number 8, I see an f of x function. I see a g of x function that incorporates f of x. And finally, they want which of the following is f of x plus g of x. I'm immediately thinking Desmos. So on Desmos, I plug in my first f of x function. And remember, since f of x is defined, I'm able to just type in the g of x using f of x. And you can see it already gives me a second graph. And finally, they just want to know what f of x plus g of x is. And that gives me a third graph because both of these are now defined. So I want to hide both of these. And all I have to do is type in my answer choices until one of them match, right? And what's nice too is most of these have similar formats. So like all I have to do is change this to a 9 for B, change this to a 42, and change this to a 51. So it's really not that bad to type in a few answers, and it looks like it's definitely going to match. Answer choice B. Number 9, I see my function here, and I see that one solution can be written in this form. So I know I'm already jumping on Desmos. I have my original function typed in here. And remember, it can be a good habit to get everything to one side of your equation and then get rid of your equal 0. Sometimes your lines aren't going to show your dots like this. And you can see if I zoom way out, it's just straight lines the entire time. Other times you'll want to see your actual quadratic for those like no solution, one solution, two solution quadratic problems. So it's an easy fix. I just add my 18 to both sides, which makes this equal to 0. And then you just get rid of your equal 0. And you can see if I zoom out enough, it does turn into a parabola. So we have that established. We still have our two x-intercepts here. And we also have our solution form written down here. So again, in this problem, they do tell us that it is x equals, but in problems they don't, make sure to add your x equals because it visually shows your solution instead of just numerically. So all I have to do is slide my k back and forth until it lines up with my two other solutions, right? So if I slide it this way, it looks like we're getting close to -6. Not a solution on my page, so I slide it the other way, and we're getting close to +6. I jump back to my problem here, and I do see that +6 is going to be a solution for k. Number 10, I see a function with two constants, a and k, and they give us two x, y points, and they want us to solve for the value of k. So we're going to have two nice Desmos ways to do this. We're going to have our more like intuitive, kind of how you do it by hand, but through Desmos. And then we're going to have our regression method. So I'm going to pull up the kind of by hand, but on Desmos way first. And that's going to be, we have our original equation. All I did was made two new equations, replacing the y with my two y values. I replaced my x with my two x values. And then instead of having a and k in our equation, Desmos likes to solve for x's and y's. So I just replace my a and k with x and y. It instantly gives me my coordinate. Since my x replaced a, my a is 45. And since my y replaced k, my k is 80. This is pretty much how you would do it by hand anyway. So this is like a nice intuitive method, but then we have our easier regression method. And all that is you type in your original equation, you replace your y and x with y1 and x1, you replace your equal sign with a tilde, and all I did down below is plugged in my two values for x, my two values for y. It instantly gives me my a and my k value, and I am done. We'll jump back here, and our answer looks like it's going to be C. Number 11, I see a big g of x function with one constant r. They also tell us that this passes through the xy point. So technically, I could already plug in -1 for x, 0 for y. I could solve for my r value, and then once I have r, I can plug in 0 because that's technically an x value. I could plug in 0 for x and solve for my y, right? Or we could throw all this in Desmos, right? So all I did again is I plugged the whole equation in. I replaced my g of x with y1. I replaced my x's with x1, and I replaced my equal sign with a tilde. What it does is it automatically gives me r is equal to 1, which it is, if I plug in my point. So I just made sure to say my x was equal to -1, my y is equal to 0. So that's great. We have r is equal to 1, but remember, I want g of 0. Of course, I could just scroll over on my graph and jump up to, my y-intercept. But like, what if it was a more technical value? They wanted one that doesn't necessarily give me a point, right? So all I have to do is we can replace r with 1. And again, they're telling us x is 0, so we don't need to plug in a y value. We're going to say, okay, what happens when x is 0? And they want us to solve for y. You can see here it is right here. y1 is going to equal 27 when x is 0. I jump back to my paper, and I know it's going to be A. Number 12, if k is a constant greater than -40, okay, maybe something like -39, which of the following are solutions to the equation? So I'm already picturing, if I just throw this equation in Desmos, I replace k with -39, it should show me my two vertical lines and my two solutions. So I pull up Desmos, and I see my function here. All I did was replace the k value with -39. I see my two solutions here. I go ahead and export them over. And then my answer choices, Roman numeral 1 is -40, so we already know that's right. Roman numeral 2 is -2 times k, so -2 times -39. Positive 78, it's not going to cut it. Roman numeral 3 is 1 plus 2k, so times -39. I get -77. It looks like it's going to be Roman numeral 1 and 3, or answer choice D. Number 13, I see an x function, and they want a solution. You already know I'm jumping on Desmos. So I plug my function in here, and we run into this problem that happens every once in a while where it's not giving me my exact x-intercepts. So if you ever run into this problem, and it's just a good habit to have in general, is you want everything on one side and then you get rid of equals 0. So if I just subtract 49 over 13x to both sides, I would get a 0 on this side, and I would get a negative 49 over 13x on the other side. Technically, I would have an equal 0, but you get rid of that equal 0, and magically my two x-intercepts appear. I don't care about the rest of this, just these 2 points. I go ahead and I export both of them. And then in my answer choices, if I need to, I could just start typing my fractions to see if they match, right? Like 2 over 7 is not going to match, 1's not going to match, and finally answer choice C, 7 over 3, is going to get me one of my solutions, so we know that C is going to be our answer here. Number 14, we have a right triangle ABC, and I drew it out here. Let's make sure everything matches though. We got AC is 40. And point D lies on AB such that E lies on CB, and this line here is going to be parallel to AC. That's important because this smaller right triangle is going to be overall similar to our bigger ACB triangle. Down below, they say CE, that's this little guy, is 1/3 of BE. So if we give the smaller one, this one x, we could give BE 3x because it's 1/3 of it, right? And I don't want to just stop there. I want my overall length of CB is going to be 4x. The reason why we want to do that is these are always going to be proportion problems. We want to compare, the smaller triangle's height DE to the bigger triangle's height AC. So I can already start that. Let's call that maybe H. So H compared to 40, and that's why they had to give us these base lengths, because if H is my smaller height, my smaller base is going to be 3x. And then since 40 is my bigger height, my bigger base is going to be 4x. All I have to do, I can get rid of my x's now, and I can say, well, how do I get from 4 to 40? That's times 10. So I would do 3 times 10, and my height, or DE, should be equal to 30. Not bad at all. Number 15, we have 5 identical pentagons, 4 rectangles, and 3 triangles, and they want to know the sum of the interior angles. Well, triangles is not bad. That's going to be 3 triangles times 180 internal degrees each. And then we have 4 rectangles, and each of those is going to be 360 each, right? 4 90s. And then for pentagons, we know there's 5, and we could just reiterate that rule real quick. So to get internal degrees of a polygon, it's going to be your number of sides minus 2. And then you take that and you multiply by 180. So all we're going to have to do here is penta 5, so 5 minus 2, or 3 times 180. And that should get us 540 internal degrees for a pentagon. So finally, it's 540 times 5 plus these other 2. And if you do all this math and you add it up, you should get 4,680 for the sum. Number 16, triangle PQR is similar to triangle STU. We only got to draw one triangle here. This is going to be P, Q, and R. And that's going to be corresponding to S, T, and U. And they tell us that Q and T are the right angles. Next, they say cosine of P is 11 over square root of 461. So cosine, ka, the cosine of P is going to be equal to our adjacent over our hypotenuse. So our adjacent here is going to be 11, and our hypotenuse is going to be square root of 461. And they tell us next, what is the value of 1 over sine of u? Well, let's just do sine of u first. Sine, so, is going to be, we can write it over here. Sine of u is going to be equal to our opposite over our hypotenuse, which is going to be 11 over square root of 461. But since it's 1 over that, you actually just do the reciprocal. So I should be looking for the square root of 461 over 11, which is d. Number 17, a rectangular training rink is surrounded on all sides by a plastic walkway of uniform width x feet. So I assume this is the training area. This is the plastic walkway. The rink itself measures 50 by 30. So 50 length, 30 height. And the total area of just the plastic walkway part is 1104. So it's going to be a little tricky, but it's analogous to like you have the bigger shape minus the smaller shape to get that like in between part. So we do want to get our overall area first. So the length of this shape is going to be 50, but you have x to the left and x to the right. So our length is technically 50 plus 2x. And then for height, it's the same thing. It's 30 plus this x up here plus this x down below. So it's going to be 30 plus 2x. And that gets us our overall area, but we just want the walkway. So you'd have to subtract this center training part. So minus, that's just going to be 50 times 30. And this should all be equal to 1104. Now all I have to do is throw all of it in Desmos, and you can see everything's typed up here, and it gives me my solution of x is equal to 6. Not bad. Number 18. The figure shows a circular ice skating rink surrounded by this plastic walkway that's x meters wide. The rink has a radius of 25. And the total area of the plastic walkway, just this white part, is going to be 2361. So again, similar to the last one and similar in general to like a bigger shape minus smaller shape gets us that leftover part. So we want the area of this bigger shape first. I can look at my equation sheet if I have to. The area of a circle is going to be pi r squared. So down below, we want to be careful here. We know it's pi, but as for the radius of our bigger shape here, it's actually 25 plus this extra x. So 25 plus x, and then that squared. And that would get us our overall area. But remember, we want just the area of the white part. So we got to subtract out that middle part. So that's going to be pi. Radius is just 25 of this part squared. And this is all going to be equal to 2361. So again, to solve it, I throw it in Desmos. And as you can see here, we have our first or overall shape minus the smaller circle equals our total. And I can see my number here is about 12.1. They do tell us in the problem to round to the nearest integer. So our x is just going to be 12 here.
Perfect.